You know how a brand new shirt collar stands up perfectly, but after a while, an old one just gets kind of soft and floppy? Well, today we're pulling back the curtain on the invisible technology that gives our clothes their shape and structure. It's the secret architecture that makes a garment look and feel really high quality, and it's probably something you've never even thought about before. I mean, really think about it. Why does a new blazer lapel have that perfect roll while an old one just looks limp? Or how do shirt cuffs keep that sharp edge for years and years? It's not magic, it's actually engineering. And it all comes down to solving this one problem. How do you give soft fabric a memory, a backbone? And the solution is, well, it's brilliantly simple. Hidden between the main fabric, the part you see and touch, there's another layer working behind the scenes. It's a support system, either fused or sewn right into the garment to give it strength and shape exactly where it's needed most. That hidden layer has a name. It's called interlining. It really is the unsung hero of the apparel world. Its entire job is to support, to reinforce, and to control the shape of our clothes, making sure they have the look and the quality that the designer wanted. It is, quite literally, the garment's skeleton. So here's what we've got on tap. We've just met the secret skeleton. Next, we're going to compare the two main types, sewn and fused. Then we'll dive into the magic of fusibles, run through the different coatings you can choose, see how to get a perfect bond, and finally, we'll clear up that common confusion between interlining and lining. All right, section 2, sewn versus fused. Let's look at the two fundamental ways to do this. This is really a story of old world tailoring meeting modern industrial production. You know, the classic traditional method versus the high-speed engine of the ready-to-wear industry. Okay, so on the left, you're looking at sewn interlining. It's a totally separate piece of fabric that's been carefully stitched in place. This is a time-honored classic technique. But on the right, that's fusible interlining. It has a coating of heat-activated adhesive, basically high-tech glue, that bonds it directly to the fabric using heat and pressure. Now, what's so fascinating about this chart is how clearly it explains the entire modern fashion industry. Just look at that fusible column. Low labor cost, less processing time, and perfect for large-scale production. This is exactly why it dominates the market. Sewn interlining is a craft for sure, but fusible interlining is an industrial process. It's the engine behind pretty much all the ready-to-wear clothes we buy today. So, since fusible is the type you're going to encounter almost everywhere, let's take a closer look at how it actually works. The real magic is all in the bond that gets created between the inner lining and the garment fabric. Okay, so a fusible inner lining is basically a base fabric that's been coated with these tiny dots of a special adhesive. It's called a thermoplastic resin. When you heat it up, this resin melts. Then, as it cools, it solidifies again, creating a really strong bond with the main fabric of the garment. But as you can imagine, not all of these adhesive resins are created equal. Different clothes have different needs, right? Some need to be washed in water, others have to be dry cleaned. So manufacturers have a whole menu of different coatings to get the job done right. For those everyday items you just throw in the wash, like your shirt collars and cuffs, the go-to choice is polyethylene. It's specifically designed to handle water, keeping those parts of your shirt looking nice and crisp. Now, for more tailored pieces like suits and blazers, things that are destined for the dry cleaner, polyamide is the industry standard. It's formulated to resist the chemical solvents they use in that process. Then you've got polyester. Some people call this the ideal interlining because it has fantastic resistance to both water and dry cleaning solvents. It's kind of the versatile do-it-all option, though it does tend to be a little bit more expensive. And finally, there's polyvinyl chloride, or PVC. This is another one of those versatile workhorses that's used all the time for outerwear like coats and jackets, mainly because it's also good for both washing and dry cleaning. Okay, so you've chosen your fabric, you've got your inner lining, now for the most critical part, actually creating the bond. Getting this right is a really delicate balancing act between three crucial variables, which the industry calls the fusing triangle. These three things, temperature, pressure, and time, have to be in perfect harmony. First, temperature. You need enough heat to melt the resin, but obviously not so much that you scorch the fabric. Second, pressure. You need that to push the melted resin into the fabric's fibers for a really strong bond. And third, time. The precise duration you apply that heat and pressure so the bond can set. If you get any one of these wrong, you're in for trouble. And that trouble definitely has a name. As our source material warns, if your temperature or pressure is too high, the resin just flows way too much. And this leads to two really common defects: strike back and strike through. So let's start with strike through. This is what happens when the melted resin is forced all the way through the main fabric. It shows up as these tiny, shiny, or discolored spots on the visible outer surface of the garment. And believe me, it's a permanent and very noticeable flaw. This diagram explains it perfectly. See, the resin is supposed to stay right in the middle, bonding those two layers together. If it goes up through the main fabric, that's strike through. If it goes down and oozes out the back of the inner lining, that's strike back, which can seriously gum up the fusing machine. Both are clear signs of a process that's not being controlled properly. Now, maybe the most common defect you might have even seen on your own clothes is bubbling. The technical term is localized delamination, and it just means the bond has failed in certain spots. The garment might look totally fine at first, but after a few washes or just some regular wear, these dreaded bubbles appear. And this is what it looks like in the real world. This really unsightly puckering happens when that fusing triangle was off. Maybe not enough heat, or not enough pressure, or not enough time. The bond was just never strong enough to begin with, and now the inner lining is literally separating from the fabric. All right, let's move on to our final section and clear up a really common point of confusion. People often use the terms lining and inner lining like they're the same thing, but they are two completely different things with two very, very different jobs. Let's start with lining. When you open a suit jacket and you see that smooth, often silky or patterned fabric on the inside, that is the lining. Its purpose is to cover up all the inner construction, make the garment comfortable against your skin, and help it slide on and off easily. So here's the crucial difference. Interlining provides structure. It's the invisible skeleton that's sandwiched between the fabric layers. Lining, on the other hand, provides comfort and a clean finish. It's the visible inner skin of the garment. The easiest way to think about it is this: skeleton versus skin. It's really that simple. So, the next time you put on a crisp shirt or a tailored jacket, you'll know all about the hidden skeleton inside that's working to give it shape and form. It kind of makes you wonder, doesn't it? What other invisible technologies are all around us, quietly shaping our world in ways we never even notice?